So in this video, I will be solving different types of time and work questions which are more important as per the exam point of view. In different types of competitive exams, we will see these kind of questions. I will try to cover the most important types and varieties of questions that are there in the time and work. Now, before starting to solve the time and work questions, I have to make sure that we are acquainted with this formula, which is efficiency is equals to total work upon number of days or hours. Now, why? Because this is the most important formula when we come to solve the time and work questions. What exactly is efficiency? It means the amount of work that a particular person can perform or do in one day or in 1 hour, right? So efficiency is actually total work upon number of days or hours. Now these number of days or hours are the total number of days or hours which are required for that one particular person to perform the entire task, right? So efficiency is total work upon number of days. And also just make sure when you are making the equations, you have to always make sure that you are dealing with efficiency. For example, this A can complete her work in 40 days, right? Now here, and B can complete in 30 days, let's say. Now here you cannot directly equate these A and B here, because first of all we have to convert those A and B's into the A and B's efficiency, and then we can equate these, or we can substitute in any other equations, right? Thank you. So now this is our first question, and it is kind of a most basic questions you can say. Here worker A is taking 8 hours to do a job. Worker B takes 10 hours to do a same job. Now how long should it take both A and B working together but independently to do a same job, right? Now first, in this type of questions or any first of all just understand these basic points. You have to find out, in this type of questions you have to find out work, right? Total work, because in efficiency you need total work, right? While finding the efficiency you need total work. So total work, while finding the total work, you can directly take W, directly consider W and solve this. Otherwise, there is this one basic way where A is taking 8 hours, right? And B is taking 10 hours. So amount of hours or days that both of them are taking, take the LCM of these, that is 8 and 10. When you take LCM of 8 and 10, it is, while finding the LCM, we have to boil down these numbers into the co-prime factors, which is 2 into 4 and then again 2 into 2. For here we have 2 into 5. Now for these two, first write down the co-prime factors of the first number, which is 2 into 2 into 2, right? These are the three co-prime factors of the 8. Now try to find the common numbers between the co-prime factors of 8 and 10, which is 2, right? So 2 here and 2 here, both are there. So when you find the common factors, you do not need to write them again. Now here, when you are writing the 2 and 2 and 2, again we have 2 here. We do not need to write it here. We just have to write this 5, because we do not have 5 here. Multiplying this, we will get 10 to the 20, 20 to the 40. So 40 units is your total work. Now, as for the formula, your efficiency is equals to A's efficiency. What would be the A's efficiency? It will be total work upon number of hours or days that A is taking, which is 8. So 40 units. So actually this 40 units is our assumed total work, right? It is not exactly our total work, but it is assumed total work. By considering this total work, you can solve the question. So 40 by 8 is 5. So 5 actually here is the efficiency of A, right? So 5 units can be performed by 5 units can be done by A in 1 hour, right? So in 1 hour A can do 5 units. Similarly, B's efficiency is 40 upon 10, which is 4 units, right? So you can say, from here you can see that A and B in 1 hour can perform, in 1 hour A and B can together perform 5 plus 4, that is 9 units, right? So in 1 hour A and B together can perform 9 units. So to complete this total 40 units, if they are working together, how many hours are required? Which is 40 upon 9. So this is our first question's answer. So 40 upon 9 hours would be required to do the same job by, right? So A and B working together to do the same job would require 40 upon 9 hours. Now this is our second type of question where A and B together can complete a piece of work in 4 days and A alone can complete the same work in 12 days, and we have to find in how many days can B alone complete the work. Now in this type of questions you can directly consider W as your total work. You can consider W as the total work. Like in the previous questions, actually why we considered the LCM, because there we had A and B separately how many days are required for A and B alone we are given, right? So here you can directly consider W. There it was easy to directly find out the LCM. Here also the like 4 and 12 LCM you can get, right? And then you can solve the questions. Actually the one basic thing you can consider your W as anything. Just to simplify your calculation, we will consider our LCM as a factor, LCM as our total work. Why? Because in the time of division, in the time of multiplication or division, or simplifying the equations, it will be much easier when you are dealing with the numbers which are divisible, right? Therefore we will actually take the LCM as our total work. Now in this question you can directly consider W, or similarly like the previous question you can consider the LCM of this, LCM of 12 and 4. Here I am going to consider W, right? So A and B together can complete a piece of work in 4 days. What does that mean? A and B together can complete a total work in 4 days, right? In the previous question, like A was able to complete total work in 8 hours. Similarly here A and B alone actually altogether they can complete a total work in 4 days. Then what would be the A and B together efficiency? In both the cases, even though we have a individual work or the together work, efficiency formula is same, which is total work upon number of days. So here 4 days are taken by A and B together, right? Now, so therefore A and B's efficiency, A and B together efficiency would be equals to W upon 4, right? W is your total work and 4 days are required for A and B together to complete the work. So A plus B's efficiency would be equals to W by 4. Now A alone can complete the same work in 12 days, which means what would the efficiency of A alone? A's efficiency would be total work upon 12 days. Here you can see that now we need something that would be divisible by 4 and 12. You can consider 12 and 4's LCM, which is 12. So directly W can be your 12, right? You can take 12 as your W. I will actually solve by taking the W as 12 after this, right? So now as I've previously mentioned the fact that you always deal with efficiencies equations. Now here you have A efficiency, you can directly substitute this A's efficiency in this equation. Why? Now when you say, like for example, A is taking 12 days. If you want to substitute this A 12 days here, like 12 days plus B is equals to 4, this will be totally wrong. You cannot deal with days while you are substituting any days inside this equation. That is completely wrong. You can do that with efficiency, right? So now A, you can substitute W by 12 in the place of A here, that is W by 12, here that B here, and would be equals to W by 4. Now by this we can find B's efficiency, which is, so B would be equals to W by 4 minus W by 12. Taking the LCM here, W 4 and 12 LCM, what is 12, right? So 3W by 12 minus W by 30, which is 2W by 12, which is W by 6. So W by 6 is B's efficiency. W by 6 is B's efficiency. So B's efficiency is W by 6. And what is efficiency? It is 1 day or 1 hour work. As per the given question, it is days. So in one day B can complete W by 6 amount of work. So how many days would be required to complete total W, right? W is a total work. So how many days would be required to complete a total work? So if we cross multiply, we will get 6 days. So 6 days are required for B to complete the total work. Now if we consider W as a 12, what would be the A plus B's efficiency? A plus B's efficiency would be 3, right? The 12 by 4. And what would be the A's efficiency? It would be 12 by 12, which is 1, right? So you can see here in 3 units. So in one day, A and B together can complete 3 units, and in one day, A alone can complete 1 units. So if we substitute this 1 in here, 1 plus B equals to 3, B is 2. So in one day, B can complete 2 units of the work, right? So if in one day, if B can complete 2 units of the work, so in how many days it can complete 12 units of the work? So that is 12 units by 2 units, which is 6, right? So this is our third question. Here, A can do a piece of work in 7 days for 9 hours. So in each day, A is working for 9 hours, and it is getting done in 7 days. So for 7 days and 9 hours, it is taking for A. For B, he can do it in 6 days of 7 hours. So for 6 days, he is working 7 hours each. Now how long will they take together? Working together 8 into 2 by 5 hours a day, which means 40 plus 2, that is 5. 42 by 5 hours a day, right? So now for simplifying the calculation, we can directly convert the days into hours. So A is working for 7 days, 9 hours each in each day, which means for 7 days 9 hours, which is 63 hours. So A can finish its work in 63 hours. Similarly, B can finish its works in 6 days and working for 7 hours. So for 7 hours, B is working for 6 days, right, which means 42 hours. So B can complete total work in 42 hours. Now what would be the, actually from this we can find out the LCM, right? We can get the LCM of 63 and 42. What is that? See, by finding the LCM like this, 9 into 7 it's 63, which is 3 into 3 into 7. For 42 it is 7 into 6, 7 into 2 into 3, right? Now as I've already told you, first you need to write the equivalent factors of the first number, which is 3 into 3 into 7. Now find the common factors in between them, which is 7, and here we have 3 also. We do not need to write it again. We have 2 left, right? So we just need to write these 2. By multiplying this, we will get 126. By multiplying this, like 9 into 7, 63 into 2, that is 126. So our total work is 126 units, right? Now what would be A's efficiency? A's efficiency would be total work, that is 126 upon 63, right, which is 2 units. So A can complete 2 units in one day. Similarly, for B's efficiency would be 126 upon 42. B's efficiency would be, I think it is 6, yeah. So it is 3 units, right? So B's efficiency is 3 units. Now we need to find out how many days will be required. How long will they take means how many days are required. If they are working 8 into 2 by 5 hours, which means 8 into 2 by 5 means what? It is 42.5, which 40, 8 into 5, 40 plus 2, 42 by 5, 42 hours a day. So in one day they are working for 42 by 5 hours. So if we just find for this 42 by 5 hours, so in only one day how much they are doing. So in 1 hour, we know, as we have completely converted this in hours, we can find it for 1 hour, right? So for 1 hour, how much work will be done? As in 42, it would be 2 plus 3, that is, so 1 hour would be 2 plus 3 units, which is 5 units. So in 1 hour, A and B together can complete 5 units, right? So in 42 by 5 hours, how much work would be done? It would be 42 hours, or 42 units, sorry. So 42 units of the work will be done in 42 by 5 hours, but for only one day. Now if in one day now we need days, right? And this 42 by 5 hours is for one day, right? So now similarly, if they are working for how many days, and for these hours how many days will be required for them to complete this work. So if in one day they can complete this 42-hour units of the work, so how many days would be required for them to complete 126 units of the work, which is our total work. So it would be 126 by 42, which is 3 days. I hope you get it. Now initially what we have found out here, we have just found this 42 by 5 hours. In 42 by 5 hours, how much they are doing, which is 42 units, right? Now, and this is their 1 day work. Why? Because in 1 day they are working for 42 by 5 hours. So in how many days they will complete 126 units, which is 3 days, working for 42 by 5 hours in each of the day. So now this is our fourth question. Here A and B can do a piece of work in 18 days. B and C can do it in 24 days. A and C can do it in 36 days. So in how many days A, B, C finish it together, working together and separately, right? So first of all, A plus B can complete in 18 days. B plus C in 24 days. And A plus C in 36 days. So here you can find the LCM of these three numbers, because it is much easier to find the LCM here to get our total work, assume total work, right? Because it is not our correct total work, it's just a assumed total work. So LCM of 18, 24 and 36, which is 18, 24 and 36. Find the co-prime factors, which is 9 into 2, and here 3 into 3, which is 3 into 3 into 2. Here 8 into 3, here 2 into 2 into 2. So here, which is 2 into 2 into 2 into 3, right? For 36 it is 9 into 4, which is 3 into 3 into 2 into 2. Now, as I've already said, that first you have to find out the common factors and eliminate eliminate writing those again. So first number is 3 into 3 into 2, right? So as already we have 3 here, right, 2 here, so we just need to write this double 2's here. So 3 into 2 into this double 2's, which is 2 into 2. Similarly for this, try to find the common factor now in this and this, in the third number and these for the combination of second and first that we have found out from this and this. So 3 already we have, 3 here, 2 and 2. So we do not need to write any number from the third number. So by multiplying this, we will get 9 into 2, which is 18, 18 to 36, 36 into 2, 72. So 72 units you can consider as your total work. So what would be the efficiencies of A plus B? So A plus B's efficiency would be equals to total work, that is 72 by 18, which is 4. So in 1 hour, in 1 day here, as days are mentioned here, so we have to go for days. So in 1 day, A plus B can complete 4 units. Similarly for B plus C can complete 72 by 24, which is 3 units, right? So 24 3s are. And now A plus C can, what is the efficiency for A plus C? That's 72 by 36, that is 2 units. So if we now, as these are the efficiencies equations, you can directly add this, which is 2A. We will adding this and adding this. So left hand side and the right hand side, if we are adding, we will get, right, A plus A, this 2A, B plus B, 2B and 2C. So 2A plus 2B plus 2C, which will be equals to 4 plus 7, that is 4 plus 3 is 7, 7 plus 2 9, which is 9. So A plus B plus C is equals to 9 by 2. Here, that what we have got efficiency for A, B, C together, working together, that is A plus B plus C. They can complete 9 by 2 units of the work in 1 day. So in 1 day they can complete. So in 1 day they can complete 9 by 2 units of the work. So in 72 units of the work will be completed in how many days? It would be 72 into 2 upon 9, that is 16 days are required for ABC together, working together. Now if we say separately, here directly, now as we have these equations like this, we have these 4 equations, we have this And now this is also efficiency equation only, right? This is also efficiency equation, and these three are our efficiency equations. You can directly substitute this and get the individual efficiencies. Like for example, this is the first equation, second, and this is third, and this is fourth equation. Now from first and fourth equation, you can substitute a plus b value, that is 4 in this, right? For example, 4 plus c. So we have a plus b as what is a plus b value? It is 4. A plus b's efficiency is 4. It is 4. A plus b plus c, it is 9 by 2, right? Substituting this a plus b here, that is 4 plus c is equals to 9 by 2. You will get c's efficiency, individual efficiency, right? So c would be equals to 9 by 2 minus 4, which is 1 by 2. So our c's efficiency is 1 by 2. So in one day, c can complete 1 by 2 units of the work. So for 72 units, it will complete it in how many days? That is 72 into 2, which is 144 days will be necessary for c to finish total work. Similarly for a and b, b plus c is given as what? B plus c is given as 3 units. Here we can see b plus c value is 3 units. Substituting this 3 b plus c in this fourth equation, we will get a's efficiency is equals to 9 by 2, which is, so a would be 9 by 2 minus 3, which is 6, that is 3 by 2. So in one day a and b a can complete 3 by 2 units, right? So 72 units will be completed in how many days? That is 144 by 3, which is 144 by 3 4s are 12, and then again 24, that is 6. So 8. So 48 days are necessary for A to complete the total work. Similarly for B, we can find out by using the third and the fourth equation. We have a plus c value, which is 2. A plus c is 2. So directly substitute here, which is, so a plus c is 2, right? So 2 plus b is equals to 9 by 2. So b would be equals to 9 by 2 minus 2, which is 9 minus 4 by 2, which is 5 by 2, right? So in one day 5 by 2 can be completed by b. So 72 units will be completed in how many days? Which is 72 into 2 by 5, which is 144 by 5 days, which is 144 by 5 days. 72 into 144 by 5. So this is necessary for completing the total work for B. Now this is our fifth type of question. Here A is twice as good as workman as B. When we are comparing A two persons with any of the aspects, we are always comparing with its efficiencies, right? Which means now A is twice as good man is what? It means that A is more efficient than B, right? Means A is twice as efficient as B is. So now, and together they finish a piece of work in 18 days. So in how many days will A alone finish the work? Now here A is twice as good a workman as B. Now just, and in this kind of sentences, just go with the second person. Now first write the efficiency of B. Just whatever efficiency that you can, just consider it as X, right? Now if B's efficiency is X, which means now A is twice as good as B, right? So A's efficiency would be twice X, right? Now here just make sure that you are always comparing. Whenever you are comparing, you have to deal with the efficiency. Now when they work together, they finish a piece of work in 18 days. Now when A and B together are there working, they can do a work in 18 days, which means when they are together, their efficiency would be equals to, just consider the total work as W. Here we have to consider it as W because there is no other option. Otherwise you can just consider it as some factor of 80, right? I'm just go with the W. I'm just gonna go with W here. So W by 18 is our efficiency for A and B together. Now single efficiencies are given, right? Even though it is in the X format, we have the efficiencies, right? Just substitute this in this. So X A, in the place of A it would be 2x, plus in the place of B it would be x. It would be equals to W by 18, right? Now, in how many days A alone can finish the work? Now, we can get the x value from here, which is 3x equals to W by 18. So x would be equals to W by 54, right? Now, substituting this x in place of that, we can get the efficiencies now in W format. So A's efficiency would be equals to 2 into W by 54, which is W by 27, right? 27 is a 54. Similarly, B's efficiency would be equals to 2x, that is simply W by 54. And efficiencies means what? Just consider in 18 days. Here we have days format, right? Here we have days. So just go with 1 day. So in one day, A can complete W by 27 of the work. Here it is for A. In 1 day A can complete W by 27 of the work. So total work, that is total W, will be completed in how many days? W into 27 by W, which is 27. So A alone can finish the total work in 27 days. So now this is the sixth type of question. A can do a certain job in 12 days. So we have data for A. A can do a certain job in 12 days and B is 60% more efficient than A, right? Now than A. So just consider A's efficiency as X, and so B's efficiency would be 60% more. More means what? Plus. Whenever we see more, we have to plus. We have to use plus, right? So X plus 60% more than A, right? So that means 60% of X plus X. So it would be 60 by 100 of X. You can do it this way, or either you can directly take, if A is 60 more, right? So you can directly take A's efficiency as 100, B's efficiency would be 160. You can directly take like that. I'm going to go with this here, right? So A's efficiency is X, B's efficiency is 60 by 100, which means X plus 6 by 10. 6 by 10 means what? 3 by 5. 3 by 5 of X, which is 5x, that is 8x by 5. So now we have found out here A efficiency and B's efficiency in the form of X, in the X form, right? Now how many days does B alone take to do a same job? You can consider W as your total work. You can consider W as your total work, right? Now, or you know what, actually in the previous questions I have taken W, right? So I'm gonna take 12 factor here, 12 factor. Just to simplify the calculation, we take LCM, right? Now LCM as a total work. So in this question we will just take simply 12 factor, or here we have 5. Just try to find out the terms that will be, that in the future we have to divide, right? So here I'm just gonna take the 12 factor 60, and also for the 5, so 12 and 5, that is 60. So I will consider our total work as 60, right? Because in B's efficiency we have in denominator 5. Just for the future, if we want to divide anything with 5, we will consider 60 as your total work, and definitely 12 factor. So 12 and 5 LCM is 60. Now total work is 60. What would the A's efficiency from that? It would be W, that is total work, that is 60 by 12, which is 5, right? But like from here we have considered A's efficiency as X, so what we have got the X value as 5. We've got X value as 5. So if we directly substitute this X in here, what would be the X, what would be A's efficiency? Here from that we can get that A's efficiency is 5. What would be the B's efficiency? It would be 8 into 5 by 5, which is 8. So B's efficiency here is 8 and A's efficiency is 5. So if B's efficiency is 5, how many days are required for B, right? For B. So in one day, right? In one day B can complete 8 units of the work. So in how many days he can complete 60 units of the work? That is 60 by 8. 60 by 8 is the total answer, which is that if we divide it with 2, it is 30 by 4, 15 by 2 simply. So 15 by 2 days will be necessary, will be required for B to do a job.